All right. Today is lesson 9-7, factoring special cases. We are going to factor perfect square trinomials and to factor the difference of squares. The perfect square trinomial we have on the key concepts are a squared plus 2ab plus b squared equals, and then you split them apart and it will be a plus b and a plus b. If you look on your work, you're going to have a number that's perfect square here and a perfect square here. And if it is a perfect square, this will work perfectly. I'll show you in a couple minutes how that works. Then you also have what's called the difference of two squares. And you will always have a perfect square and then another perfect square. And then in the middle will always be a subtraction sign. And if you do have those, you'll have your answer would be a plus b and an a minus b, unsquaring everything. So let's try it. On example 1, you have a perfect square for your x squared. So I'm going to unsquare it. And then I have a perfect square on your third number, and that would be unsquaring it would be 4 and 4 because you were unsquaring 16. Then you're going to put negative and negative in the middle. And now we're going to check and see if our middle works perfectly with this. You're going to take your outer and your inner. So you're going to go x times negative 4, which is negative 4x. And your inner, and that would be negative 4 times x, which is negative 4x again. And negative 4x minus negative 4x is negative 8x. And that is your middle, so here is your answer. B. Again, you have a perfect square for both the first and the last number, so I'm going to unsquare both of them. I have 64, which is 8 and 8. And then they're both positive, so I'm going to put a plus plus. I'm going to fix that up just a little bit. And in your head, you can just go 8n plus 8n equals 16n, so there's your middle. C, I'm going to break up C and C. And 25, I'm going to square root 25, which would be 5 and 5. And again, I'm looking to see what my signs are going to be, and that would be plus and plus. And if I did my outer and inner, I would have 5c plus 5c, which is 10c. All right, the given expression represents the area. So here's our area right here. Now, formula of an area is area equals side squared. So we are going to find the length of each find the side length of each square. So I'm going to find the side length of A. So if I look, this is a perfect square and this is a perfect square. So I'm going to do 9g. Well, the square root of 9 is 3, so I'm going to put 3 and 3. And then unsquare g, which would be g and g. Then I'm going to unsquare 4, which is 2 and 2. And then I put plus sign and a plus sign. But it's only asking for one side length, so you're just going to go 3g plus 2. On example A, if you want to, you can just make your answers x minus 4 on A, I would do x minus 4 squared, and then n plus 8 squared, and c plus 5 squared. That works also, instead of writing out twice. For B, these are a perfect square and this is a perfect square, so I'll do it with just one parenthesis this time, with a square on the end. So I'm going to unsquare 4t squared, which would be 2t, and a plus sign. And then I unsquare 81, which is 9. And there's your answer, except you don't need the squared for the B. All right. For examples 3 and 4, it's a little different. You will have to have 2 sets of parentheses for this one. You're going to do 2 sets. And you're going to have a plus and a minus. There always will be. You could put the minus first and then the plus second. I don't care. And then you unsquare each of the numbers that are given. So x squared, the square root of x squared is x. So x and x. And then the square root of 64 is 8 and 8. And there's your answer. B, you have your 2 sets of parentheses. You have a plus and a minus. Unsquare p, which would be p and p. And square 36, which would be 6 and 6. C, same idea. There's a minus sign and they're both perfect squares. So you're going to have a plus and a minus again. And you're going to do 2x and 2x. And you need 11 and 11. Nine, for D, you're going to have the same idea. They're both perfect squares. So you're going to have 3v and 3v, plus and minus, and a 2 and a 2. 25, it's a perfect square, and 64 is 2, so you're going to have 5x and 5x, a plus and a minus. And then you have 8 and 8. F, they're both perfect squares again. You have an m and a plus, an m and a minus, and then it would be 10 and 10. All right, example 5, it's a little different. They're not perfect squares, so I'm going to say to myself, what can I take out of both 10 and 40? What number can go into 10 and 40? Well, 10 can. So then I have 10. What's left over would be x squared minus 4. Now, I can break up x squared minus 4 because they're both perfect squares. So I'm going to still have my 10, and I'm going to have my 2 sets of parentheses. Break up my x and x and have my plus and minus. And the square root of 4 is 2. So it would be 2 and 2. And there's your answer. All right, let's look at B. Well, I'm trying to figure out what can go into 8 and 50. Well, 2 can. So I have 4y squared minus 25. And again, 4 and 25 are perfect squares, so you can break it up again. So it would be 2y and 2y plus and a minus. And then I can break up 25, which would be 5 and 5. And C, I can take out 3, so I have c squared minus 25. And c squared and 25 are both perfect squares, so I'm going to break up them. So break up c squared into c and c, and a plus and a minus. and break up 25, which would be 5 and 5. All right. Here are your answers for example 5, and I'll see you tomorrow at school.